Hello everyone, this is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University-Surampalem. Today we would like to discuss about the concept multiplexer. So now, coming to the learning outcomes, at the end of this lecture, student will be able to explain and design multiplexers for selecting one input from multiple sources based on control signals. So coming to the block diagram, this block diagram contains the inputs and the output and the selection lines. Now most of the time we will call from 1 to n. So this is the, if more than 1 means we call this one as 1 to n. So if we start from 0, so this is 1 minus, that is n minus 1. That is why here the inputs are from I0. So input representation is from I0 to im minus 1. So here m representation is the final highest input. So that is why m minus 1 representation. That means I0 to im minus 1 is the representation. Likewise here selection lines, S0 is the first selection input and Sn minus 1 is the nth selection input for this particular multiplexer device. Now, a digital multiplexer is a combinational circuit that selects one input out of several inputs and direct it to a single output. So here the representation is similar. So we are simply following the concept. So 2 to the power of n multiplied 1. So this we call it as multiple or is2. So that means here the representation is, so here 2 to the power of n is the inputs and here the n representation is the number of selection lines and the output is only 1 for the multiplexer. So this is the representation for any multiplexer. So 2 to the power of n is the inputs. So number of inputs is 2 to the power of n and n is the selection lines and final 1 is the output. This is the representation of the terminals for any multiplexer. So the particular input selection is controlled by a set of selection inputs. So entirely the procedure or the operation of the multiplexer depends on this selection lines only. For selecting one output of m input, a set of 2 select inputs is required where m is equal to 2 to the power of n. Let us see, we will discuss all these things in the next slides. So this is the block diagram for the multiplexer. A multiplexer, or simply we can call this one as a mux, MUX. So also called a data selector because we can select the data, input data, and we can simply give to the output. So depending on the selection line only, we can simply select the input data. So is a combinational circuit with more than one input line, one output line and more than one selection lines. Maybe we can expect more inputs and more selection lines, but the output is only one output line. And multiplexer is essentially a multiple to one switch. We can simply call this one as a multiple to one switch because inputs are more but output is only one, where the selection of the input is determined by the values of control signals and used for data transmitting. So transmitting the data, we can simply use these multiplexers. Now coming to the 2 to 1 multiplexer, we can call this one as a 2 to 1 multiplexer. That means the representation is, we can simply represent two multiple cross symbol with 1 or 2 is to 1. So we can represent any such type of representation, but we call this one as a 2 to 1 multiplexer. Now we know, so 2 to 1 multiplexer which contains, we can also represent 2 to the power of 1 multiplied 1. That means here the selection line is only 1 and 2 to the power of 1 is the inputs and 1 is the output. So we can consider this one selection line. Here the entire selection line that is represented with S. So S is represented and the inputs are 2. That inputs, that is I0 and I1 and output is the 1. So that representation is Y here. So that means selection line is S and inputs are I0 and I1 and output is Y. So this is the representation. Now selection line is only 1, right? So here maybe it is 0 or 1. So simply we can select, if S is equal to 0, the input whatever the I0, that is directly Y. That means Y is equal to I0 when S is equal to 0. If S is equal to 1, Y is equal to directly I1. So this is the simple representation. If we observe the block diagram, so I0, I1 are the two inputs and S is the selection line and Y is the output. So if we consider I0, I1 S is also selection line, but we can also consider that one as an input. So now the inputs are 3. So now inputs are 3 means, so S is input, I0 is input, I1 is input. So if 3 inputs are there, so the combinations are totally 8. So the totally 8 combinations given here. So for this particular combinations, if the selection line is 0 for particular 4 combinations, then it simply follows the output simply follows the I0. So I0 means, so I0 here 1 1 0 0. So if we observe the output, this is directly I0. So y is equal to I0. If selection line is 1, then again the y is equal to, it simply follows the I1. So that means, so here the I1 combinations are 4. So the output is also that 4. So it simply follows the I1. So that means it is simply following the inputs depending on the selection lines. So the simple circuit here it is given, and also equation is given. So y is equal to the summation of S bar with I0, S1 with S with I1. That means here this is a simple equation for the 2 to 1 multiplexer. And so we can use this selection line with the help of the decoder circuit. So finally we can give the, with the help of this decoder signals, that means S is equal to 1 times 0 here, S is equal to 1 time 1 here. So that is given to the enabling circuit, because this is a multiplexer circuit. From here to here, this is the multiplexer circuit. So entirely we call this one as a multiplexer, and finally we will get the output as a 1, that is Y. Now coming to 4 to 1 multiplexer, this is also same. So we can represent 2 to the power of 2 multiplied 1, that means 2 to the power of 2 is equal to 4. So 2 selection lines we can expect, and output is, that is 1, and 2 to the power of 2, that is 4, that is the inputs. So here the inputs are I0, I1, I2, I3 are the 4 inputs, and 2, that is selection lines, we can write it as a S0, S1, and finally the output is Y. So here the representation block diagram is like this. And if we consider the selection lines, a combination of these 2 selection lines, we can get 4 combinations, both are 0 0 and 0 1, 1 0, 1 1, and we can expect each input at the output. That means for 0 0 combination, we can expect Y is equal to I0. So that is I0 is directly given to the Y. And if combination is 0 1, so S1 is 0 and S0 is 1, then I1 that is given to Y. So Y is equal to I1. So likewise, so each time only one input is selected at the output depending on the selection lines. This is the major procedure for this multiplexer concept. And we can write down the equation is Y is equal to, if 4 combinations are there, definitely we can follow the binary representation, that is S1 bar, S0 bar, because these 2 are 0 0 here. So that is why S1 bar, S0 bar multiplied with I0. So the output is I0. And S1 bar here 0, 1 representation, that is S0 with I1, because the output is 1, I1, plus S1, S0 bar with I2. So likewise we can write down that particular equation. And here also the selection lines depending on the decoder circuit, and finally with the help of decoder, the 4 combinations we can given put of the particular AND OR operation for this particular multiplexer, and finally we can get the entire multiplexer circuit with based on this particular depending on the equations. Now this is a simple 8 to 1 multiplexer. So we can increase the inputs, so with the help of the selection line. So this is a 8 to 1 multiplexer. If we check this block diagram, so it is simply connection that like acts as a switch. So output directly connected to maybe the I0 to I7 here, because totally 8 inputs are there, and there is an enable input also there, and 3 selection lines, that is S0, S1, this is S2. So S0, S1, S2 are the selection lines. And here if we observe, if enable signal is 0, irrespective of whatever the inputs, so we cannot get the output. So this is simple truth table representation. And finally if enable signal is 1, then only it will simply follows the selection lines. So depending on the combination of the selection lines, we can get the output, that is from I0 to I7. So each time one input is selected at the output side. So Y is equal to, so this is again entirely a decoder circuit, and each time the decoder circuit for each and every AND gate output, the product S0, S1, S2. So here the first one is S0 bar, S1 bar, S2 bar, because it is given after the inverter circuits, and which is multiplied with I naught, because my input is here I naught. So likewise the terms are there, and finally all the 8 terms that is given to the one OR gate, finally we will get the output as that is Y. So this is the simple construction for the 8:1 multiplexer, and the equation is also output is a product of that is the enable signal with the equation. We already learned the equation from 4:1 multiplexer. Likewise the same equation we are increasing to 3 selection lines, because combinations are there. According to the combinations, the inputs are increased from 4 to 8. So depending on the 8 inputs, and we are multiplied this entire equation with the enable signal. And coming to the Boolean function implementation using this multiplexer. So if any equation or Boolean function, so let us take this is the one circuit. We call this one as a full adder circuit. So design a full adder using 8:1 multiplexer. Same. So full adder contains, we have to take the truth table of the full adder. So again we have the sum and carry out. Simply we can represent this 8 inputs. So here for full adder, these are the sum and carry are the outputs, but we have to give all these as the inputs to the multiplexer, because this is a 8:1 multiplexer contains 8 inputs. So these outputs, whatever the outputs, that is sum outputs, that is directly given here, and carry outputs that is directly given here. That means for sum 1 8:1 multiplexer, and for carry 1 8:1 multiplexer we are using here. So all the zeros are given to one logic 0, all the ones are given to one logic 1. So depending on this, here the ones and zeros, we are simply connecting all these terminals. This is very simple. And coming to this, the 8:1 multiplexer is converted into 4:1 multiplexer. So we have to reduce the inputs. So depending on the inputs only we can construct the circuit. So if we observe, input is 0 for 4 combinations and 1 for 4 combinations. That is why we call this one as a bar here, A here. So for these 4 particular inputs, A is 0, that is why A bar. For this particular 4 inputs, A is that is equal to 1, that is A. So we can construct this table like this. And if we go to this equation, that is for sum 1, 2, 4, 7. So 1, 2, 4, 7. So 1 we have to make a round here, and 2 and 4 and 7 we have to mark this one as a circle. If we observe, this circle simply belongs to A, so that is why the output is A. And if this circle belongs to A bar, so that is why A bar. This circle belongs to A bar, again this is A bar, and this circle belongs to this A, so this is A. So this is the table construction. Likewise we have to construct for the carry also. So carry, that is 3, 5, 6, 7. Again we have to round for 3, and for 5, for 6 and for 7 we have to mark it as a circle. And finally if there is no circle is there for this particular column, so we can write it as a 0. Circle is in A, here also A, and if both circles are there we have to represent with 1. Likewise we have to represent, and with the help of this one, the 4 inputs, with the help of A is now input, here the sum and carry we have to represent it with 4:1 multiplexers, that is 2 multiplexers, 4:1 multiplexers. So now this is for sum and this is for carry. A is the input right now, and that A with A bar we have to give the inputs for this D0, D1, D2, D3, and finally sum is the output and carry is the output here, and the other 2 inputs are B and C in. So the B and C in are the selection lines. So this is likewise we have to construct 8:1 multiplexer to 4:1 multiplexers, and that means 2 4:1 multiplexers we have to use with the help of 8:1 multiplexer. So likewise we have to construct here. Now if any equation, that is 4:1 multiplexer, so here construction is like this. So here if the Boolean equation is like this, that f of a comma b comma c sigma m of 1 comma 3 comma 5 comma 6, this is the equation given, then simple. Again we have to represent because it starts from 1 to 6, definitely totally 8 inputs. We can construct 8:1 multiplexer. Later it is converted into 4:1 multiplexer. So this is why, this is what we have to do. So simple, the 4:1 multiplexer, the same procedure we have to follow. Before and all, for 8:1 multiplexer, so the 8 inputs are like this. At 1 we have to place 1, 3 we have to place 1, 5 we have to place 1, and 6 we have to place 1 here. So this is the truth table for the particular given equation, and with the help of this equation we have to construct this table again 1, 3, 5, 6. We have to mark the circles here. So here there is no marking, so that is why 0. Here 2 are marking, that is why 1. And here A is marking, that is A. And here A bar is marking, that is A bar. So now the inputs are these 4. So these 4 inputs are directly given to here. Inputs for this particular 4:1 multiplexer. And our final F is the output, that is the F. So here the output is F, but B and C are the selection lines here. So this is the construction of a 8:1 multiplexer to 4:1 multiplexer. That is a simple conversion. So likewise, this is also other simple from 0 to 15 means this is 16 construction. Likewise same, from A bar is from I0 to I7 and A is from again 8 to 15. The same construction. Here A is the one time we can take this one as a 0 and one time we can take this one as a 1. So same construction again. B, C, D are the selection lines here. Likewise, we have to start our work. And here, this is a equation given, but we have to first construct the truth table. So that is from 0 to 7 because 3 input terminals are there. That means A, B, C. So if 3 inputs are there, 2 to the power of 3. So totally 8 combinations. So for 8 combinations here, A bar, B, C bar. That means A bar is 0, B is 1 and C bar is 0. So 0, 1, 0 here. For this particular combination we have to give 1 and A, B bar, C bar, that is A is 1 and B bar, C bar here 0, 0. So we have to place 1 here and A, B, C. So 1, 1, 1. So 1, 1, 1 we have to place 1 here. So all these 3, because F is the equation, F is the output and 3 combinations are there. For this particular combinations only we have to give 1 here. So likewise we have to construct the circuit with the help of the truth table. So ABC are the whatever the selection lines and inputs are I0, I1, I2, I3 so on up to I7 and wherever the 1 is there, so the 1 we have to connect directly and wherever the remaining all other output are the zeros. So these are connected to 0. That is simply here the connection is grounded. So and finally we will get the output F. Coming to the advantages, so efficient data selection. A multiplexer selects one input from multiple inputs and forwards it to a single output using select lines. This makes it ideal for data routing and resource sharing. So most of the time we can select only one input. So data or the resources we can easily share. So reduction in hardware. So multiple logic functions can be implemented using a single mux, reducing the number of gates and ICs. So leads to lower area, power consumption and cost reduction. So most of the time reduction in hardware means we can simply select only one, we can reduce with the help of this multiplexers the hardware and we can reduce the area, also we can reduce the power. At the same time if we reduce all these things, cost reduction is also there. And simplifies complex circuits. That means wherever the complexity is there, we can simply reduce the complexity also with the help of this multiplexers. And most of the time these multiplexers that are used in the FPGA concepts. So FPGA construction is also uses this multiplexer concepts. Coming to the limitations, so limited by a number of select lines, cannot handle very large inputs without cascading. That means we cannot construct directly 128:1. So we can convert that 128:1 to multiples of 8:1 multiplexers. So likewise we can construct 128:1 multiplexer, there is most complexity is there, that particular 128:1 multiplexer. So we can reduce it to smaller inputs, that means 8:1 multiplexer or 4:1 multiplexer with the help of some logics. And propagation delay increases when multiple multiplexers are cascaded. So this is what happened. And susceptible to noise and signal degradation in high speed circuits. We reduce means again the routing part is increased. Definitely there is addition of the noise here. So that is why if noise is added, so definitely some signal degradation is also there. If we require high speed circuits, this is the drawback. And requires precise synchronization of selection lines. So whatever the output depends on the input, definitely it depends on the selection lines. So selection lines must be precise. That means accurate selection lines we require actually. Coming to the application part, data selection and routing in communication systems, and implementing Boolean functions and minimizing logic circuits used in ALUs and processors for selecting data paths, parallel to serial data conversion, switching in telephone networks and digital communication used in control systems to send multiple sensor signals through a single line. So these are all the applications that we are using these multiplexers at present. And coming to the summary, a multiplexer selects one input from multiple digital inputs and forwards it to single output line based on selection lines signals. It is widely used for data routing, switching, and implementing digital logic functions. Thank you.